probability theory. So as a medical practitioners, the probability theory is very, very important. So why? Because whenever you are studying about the vector-borne diseases or any disease, so it is necessary to know the prevalence rates of the disease in that particular area. So the prevalence rate is normally calculated by the number of patients affected divided by the total number of population in that particular area. So the prevalence and rate of any disease, it could be a dengue or malaria or whatever, so it's number of patients divided by the total population. So this is very, very important, because so whenever you are doing some research on a particular disease, it could be a tropical disease, or it could be a new disease like Ebola or swine flu or something like that. So it is very important to know the prevalence rate. So prevalence rate won't be readily available. So normally we take it from the past experiences or the past research done by some other researchers, or you can go through some materials of that disease in that particular area. So why the prevalence rate is very, very important? So based on the prevalence rate only, we select this number of samples to conduct that study. So for the sample selection, the prevalence rate of that particular disease is very important. This is nothing but the probability. All right. So prevalence rate in terms of when you talk about in the mathematical way, we call that as the probability or the proportion or whatever. Okay. So now we are going to deal with the probability theory. So let me explain in a classical way of defining the probability. So probability of any event A is equals to m over n. So n is the favorable number of cases divided by total number of cases. So m by n. So this is the classical way of doing definition here. So this may not be applicable when your population size is close to infinitive, right? So in that case, so m smaller number over a bigger number. So the population, the probability will almost tend to 0. All right. So whenever the population size is too big, so it's may not, this formula may not be applicable. All right. So we have to look for something else. Next, let me introduce an experiment, a random experiment. So random experiment. So any laboratory experiment is called a random experiment. In fact, our own life is random. It involves the random phenomena, because nobody can predict what is our lifetime, right? So nobody can say this many years we are going to live, or the number of hours an electrical bulb can work, or so that's why our life is full of a random phenomenon. So anything can happen at any time, right? So this we call it as a random experiment. As a result of the random experiment, you will get a result, an event. So that we call is as an event. See, for example, a simple example: when you're tossing a coin, see probability of getting a head. So what is the probability of getting a head? So you have only one head. The sample space is head or tail, right? So if you are interested in getting a head here, so your head will be 1, and the total number of cases here is 2. So probability of heading is half. So in a medical scenario, a woman is pregnant, right? And what is the probability of getting a boy child? Is what? Can anybody say? So there are 2 possibilities here, and then the other possibility is ruled out. So either a girl or a boy. Okay, the third possibility is ruled out here. So you can have only these two possibilities, girl or boy. And the father is interested in getting a boy baby. So what is the probability of getting a boy baby here? Again, is 1 by 2, right? So
yeah. So what if the father is interested in getting a girl baby? What would the probability?
yeah, so probability of getting a girl baby is half, right?
Okay.
Here probability of getting a twins is ruled out. Yeah.
Okay. Thank you, sir.